I'd never done
Alright, this is
before.
going to be the homework solutions for section 7.3 through 7.5. We start off at 7.3, number 4. So this is the one that talks about a dough recipe, calls for 3 cups of flour and 1 1/4 cups of water. And you want to use the same ratio of flour to water to make a dough with 10 cups of flour. How much water should you use? So the first part says, solve this problem by setting up a proportion. So there's a number of different ways we can set up this proportion. You can compare like quantities by doing, for example, flour over flour. So let's see, how much water should we use? It says 10 cups of flour. So in our new one, we'd want 10 cups of flour over, so if we're doing flour over water, so let me just make a little note of that. Flour over water. We could go 10 over x, that's the one we want to find, is equal to, so this is our new recipe right here, equals, and then in our old recipe we had flour, we had 1 1/4 over 3. 3 cups of, no, I have it backwards. Dang it. See, everyone makes mistakes doing math. That's why we use pencil. Would be flour was 3 and 1 1/4 was water. Okay, and then we can solve this, and we've seen the easy way to solve this, and really we're just if we multiply both sides by x and both sides by 1 1/4, then in essence we do what's called cross multiplying. So we get 3x equals 10 times 1 1/4 is, I believe, 12 and a half. Then we divide both sides by 3, and x equals, so if we go 12 and a half, 12.5 divided by 3, we get 4.166666. Well, you should learn to recognize when you see 6 is repeating, that means 2/3. Well, in this case, it's kind of weird because it's 4.166. But if you want to convert that back to a fraction, you can always just go math, fraction, boom, and so it's 25/6, which is 4 1/6. Okay, now we could also set it up as water over water equals flour over flour. So this is comparing like quantities. So if we take water in the old one, say we got 1 1/4 over how much water is going to be in the new recipe. That's what we want to find, is equal to flour over flour. So flour in the old was 3 and flour in the new recipe is 10. So we got water old over water new equals flour old over flour new. And again, we'd end up with the same exact thing. All right, now we're going to look at number 7, which is actually, it looks like it's section 7.5. It's actually 7.4, but it's on page 301. And this is the one where liquid is pouring at a steady rate from hose A, takes 15 minutes to fill a vat, and hose B takes 10 minutes. Well, what if we put them together? And so this one's a little trickier, but the way we can do it is let's figure out rates. So if we figure out rates, okay, so it says it takes the one hose to fill the vat in 15 minutes. So in 1 minute, it would fill 1/15 of the vat per minute. And so the other one would fill 1/10 of it, of the vat per minute. Right, and so let's pause here for a second and think about. So our so the one hose fills the vat in 15 minutes, and the other one fills it in 10. So if they're hooked together, we know our answer is going to be less than 10, right? Because they're working together, and the one can do it by itself in 10. So we know our answer is going to have to be less than 10. My guess would be, I don't know, 5, 6, 7, something like that. Okay, so now we have this. Now we can add these together because these two things are working together. So we've got 1/10 plus 1/15. Okay, do we want to use a calculator on that, or let's do it old school? Let's do it old school, adding these together. So let's find a common denominator. I think that'd be 30. So that means we got to times this one times 3, and this one times 2. So we get 3/30 plus 2/30 equals 5/30, and that equals 1/6. So that means together it fills 1/6 of the vat per minute. So how long would it take to fill the whole vat? So it would just take 6 minutes to fill the vat. Working together. All right, so now let's look at, this is number 4 on page 309. This is the one about, well, here, I'll just throw it up here right quick. About a television that originally cost $500 is marked down by 25%. Last week, a store raised the price of a television by 25%, and the new price is $25. What was the old price? Okay, are these the same problem? Well, no, they're actually not. So let's take a look at A and how they're different. Okay, so part A is pretty straightforward. A television was originally cost $500 is marked down by 25%. So that means it's 500. Now what we could do is times it by 0.25 and subtract that. Okay, well, let me just do that. So 500 times 0.25 equals $125. And then we could do 500 minus 125 equals 375. So that's the new price. Or, just to make it easier, let's just go 500 times, well, if it's marked down 25%, that means 75% will be remaining. And we know 75% is equal to 0.75, so we can get our answer directly like that. So the new price is $375. Now part B is a little trickier. Last week the store raised the price of a television by 25%. The new price is $500. So here what we need to do is we need to set up an equation. So let's let X is the old price, because that's what we're trying to find. And now let's see. We've got X. Its price is raised by 25%. So that means it's going to be, well, one way we could do it is we could have it as X plus, so it's up 25%, so that's 0.25X, right? And that's going to equal 500. Or an easier way to think of it is just, again, we can combine like terms here in essence, but really if it's up by 25%, that means it's 1.25 times the original price equals 500. Now let's solve for X. 1.25 divided by 1.25, X equals, alright, I need a calculator on this. 500 divided by 1.25, 400. Okay, I should. Okay, so 400. So something was $400 and it goes up 25%. Now it's at 500. And so you can see these are not the same problem, because when we take percent, we need to look at what our starting value is. And in this case, on this one, it was 500, but in this case, our starting value was 400. All right, so finally, let's take a look at This is number 22 on page 311. This is about a dress is marked down 25%, then it's marked down 20% from the discounted price. And so, this is a real life problem, right? You go to a store, you got a coupon, it says, 20% off any already marked down item, and it's already marked down 25%. And you're like, sweet, that's 45% off. No, it's not. So let's take a look. Let's say P is the price of the dress. And what a number of people did is that they said, well, since we're dealing with percents, let's let the price be $100. The original price be $100. And now when we get our answer, it'll be easy to see what's going on. So first it's a markdown 25%. So it'll be 100 times, and like we did before, if it's marked down 25%, 75% remains. So that's going to be at $75. Now we've got 20% off, but it's not 20% off 100. It's 20% off 75. So 20% off would mean we still pay 80. And so 75 times 0.8 is, I should know how to do this with a calculator. That's okay. 75 times 0.8, 60. Okay, is $60. Okay, so the original price was $60. No, 100. That's why I use pencil. Ba, ba, ba. Okay, original price, new price is 60, so 40% off. Okay, and if we wanted to do this in just one big equation, we could go 0.8 times 0.75 times 100. Right? Because what's going on here is we're saying 75% off 100. I'm sorry, not 75%. 75% of 100, so 25% off. And then 20% off that whole thing. Right? And so we get that equals 60. Now, the last question asks about, okay, so clearly the last question asks, what if it's marked down 20% first? Well, so in that case, we would do 0.8 times 100, right, and then 25% off. So we'd have altogether 0.75 times 0.8 times 100. And again, we know that these are going to be the same because multiplication is commutative, meaning if we were to reverse these, we'd get the same answer. So we already know that it's 60. So yeah, the order that you do the markdowns does not matter. Hope this helps, and have a good one.
Our goal lights and begins, feeling in my bones I never felt before. People